Good afternoon all of you. So last time in electrostatics lecture 3 we have seen the relation between your electric potential and electric field intensity. Before that you have seen about what is your potential energy, what do you mean by electric potential. So we have defined electric potential as amount of work done to take a unit positive charge from infinity to that point. I will repeat, the electric potential or potential energy is nothing but amount of work done to bring a unit positive charge from infinity to that point. Now, let us derive today an expression for electric potential due to a point charge. For that, we will take a source charge plus Q which is situated at point O. Suppose I say there is another charge in the same medium which I take as a test charge plus Q naught which is situated at point M. So the distance between your Q and Q naught is nothing but X. So suppose if I take here another point N which is situated from point O at a distance of R. So what I have taken? I have taken an N point which is at the distance R from charge plus Q, or you can say from point O. Now, if I want to take this plus Q naught charge, that is a test charge from point M to N by doing some displacement dx. So what I am doing here, I am bringing this plus Q naught charge from point M to N by doing some displacement dx here. So now, for doing this, I need to do some work. So I will write the equation for work done. So work done is always given by minus F dot dx, that is force into displacement, where this force is nothing but a Coulomb force. Now this negative sign indicates that my force and displacement both are oppositely directed. Now let's write the Coulomb force, that is F here. Coulomb force, which we can say as the electrostatic force, is written as 1 upon 4 pi epsilon naught. Whatever two charges we have here, that is plus Q and plus Q and plus Q naught, product of these two charges, that is Q naught, upon square the distance between them, that is x square. So this is my force. Once I know the force value, I will insert here in equation 1. So I will get dW as here minus 1 upon 4 pi epsilon naught Q naught upon x square into dx. This is my value of dW, that is work done. Now here, this was the work done to bring Q naught till N, that is from point M to N. I need to bring this charge. Now if I say my M is an arbitrary point and if this Q naught is situated at infinity, so if I need to take this Q naught charge from infinity to point N, so I need to do the integration, means the total work done. So the total work done, to find out this total work done, to take that Q naught charge from infinity to N, I need to integrate this. So integration of dW is W, and all other things will come under integration, that is integration of minus 1 upon 4 pi epsilon naught Q naught x square into dx. Now here we need to put in limits where I am taking this plus Q naught charge from infinity to N, means till distance R. So I will write the limit, that is from infinity to R. Now here, once we have a limits, we can integrate it. We know this 1 upon 4 pi epsilon naught Q naught will come out of integration. So I will write that 1 upon 4 pi epsilon naught Q naught upon, this Q naught, this will come out of integration with a negative sign, and in integration you will have, that is limits are important to write first. So infinity to r, inside the integration you get 1 upon x square into dx, right? So now once you get this, let's integrate further. So here I can write W, that is total work done, is equal to minus 1 upon 4 pi epsilon naught Q into Q naught integration, that is from infinity to r. This 1 upon x square can be written as x raised to minus 2 because this x square come at numerator into dx. So as in previous lecture I have told you the formula for integrating. So those who are not having maths or have dropped the maths, for them again I will repeat it. That is the integration of x raised to n dx is always equal to x raised to n plus 1 upon n plus 1. So here x as it is, role of n is playing minus 2, dx as it is. So just use that formula, you will get here minus 1 upon 4 pi epsilon naught Q into Q naught. Here after integrating I get minus 2 plus 1, so x raised to minus 1 upon n plus 1 means minus 2 plus 1, that is minus 1. Need to put n limits, that is from infinity to r. Now this minus will change into positive, that is minus 1 and this minus sign. So you will have your total work done as 1 upon 4 pi epsilon naught Q into Q naught, that is this x raised to minus 1 as it is from infinity to r. Now this x raised to minus 1 can be written as 1 by x. So I can write W is equal to, that is work done is equal to 1 upon 4 pi epsilon naught Q into Q naught, 0.2 bracket 1 upon x, limits are infinity to r. Now once you have this 1 upon x, you can insert the limits. Limits are infinity and r, and by the integrating rule, first we insert the upper limit and subtract it from lower limit. So first insert the upper limit always. So I rub this side. So here we can write the next steps. Okay. So here W is equal to, after integrating 1 by x, that is after putting the limits, you get outside we have Q naught upon 4 pi epsilon naught. First I put the upper limit instead of x, that is 1 upon r, minus lower limit, that is 1 upon infinity. So here Q naught 4 pi epsilon naught as it is. Here we know 1 upon infinity is always 0. So here you get only 1 by r. So you know work done is always stored in the form of electric potential. So here once you get a final equation, that is work done, total work done is nothing but Q naught 4 pi epsilon naught 1 by r. So we know here work done is stored in the form of electric potential. So here V can be written as this thing, that is 1 upon 4 pi epsilon naught Q upon r. This is my electric potential, right? This thing is my electric potential. So once I get electric potential equation, that is due to a point charge, I can say this 1 upon 4 pi epsilon naught is a constant thing. So here V is directly proportional to Q and inversely proportional to R. It tells us that if your Q charge is positive, then your potential, that is electric potential, should be positive. If your Q charge is negative, then your electric potential value will be negative because they are directly proportional. Then we will talk about the distance because they are inversely proportional. As I go on increasing the distance, my potential will definitely decrease or go on decreasing because they are inversely proportional. So to represent their relation, we can draw a simple graph, that is your V versus R graph. So if you draw this graph, you will have a nature which is a non-linear nature, which shows that when your R is very less, your potential is high. As you go on increasing your R value, your potential decreases. See? Because they are inversely proportional. One more thing, when you get this equation, I will name this equation, star, you can say, which is the final equation of electric potential due to a point charge. If I take instead of R infinity, so what you will get? V is equal to Q divided by infinity, which is nothing but 0. Means you can say one thing here, that is the main thing. What you can say? When our distance is infinite, your potential is 0. Means at infinity, your potential, electric potential is always 0. So this is nothing but the expression of electric potential due to a point charge. I hope this is very much clear to you. Thank you.